MCT4C, lesson 1.6. This is day 8. And just an announcement that today's day 8. Day 9 is review for this chapter, and day 10 is test. So mark that on your calendar. You probably already knew about this from class, but got a test coming up soon. So today, our goal is to use the sine law to find unknown sides and angles in oblique triangles. And oblique, remember, meant not right triangles. When it was a right triangle, we use SOHCAHTOA. Oblique triangles, non-right triangles. And we knew we could use the sine law if we had an angle side pair, just like in this first one. We see we've got this angle side pair. Right? And if we want to find angle y, we got the side across from it, we can certainly do that. So we got sine of y over y equals sine z over z. And I know a lot of you are probably skipping the write down the formula step and going right into the substituted step, which is just fine. Oops, sine 65 over 15. So if you skip right to that step, that's just great. Now I'm solving for the unknown. Cross multiply here. Calculator. Bash that in there. You get sine of y is 0.725-ish. Inverse sine of both sides, about 46 degrees. And notice, we got to worry about the ambiguous case. Y looks like an acute angle, so the 46 degrees is just fine. If it was an obtuse angle, then we'd have to go 180 minus that to get the obtuse angle, but we're good with that. And that, remember, only happens when we're finding angles. In the second one, when we want to find a side, we won't be doing the inverse sine, so we don't have to worry about the ambiguous case. It's only when we're finding angles. So in this one, we want to find side L, which is over here. Notice that we don't have angle L, so we're in a little bit of trouble straight off, but it's no big trouble. Angle L is 180, subtract 25, subtract 95, which is 60 degrees. Now that we've got the opposite angle, we can use our angle side pair here, okay, to find out what L is, and I'm going to use the substituted version. Side L over the sine 60 is equal to 15 over the sine of 25. Notice I didn't write down the formula there. I just substituted into it using sides on the top, angles on the bottom. Now solving for L. Calculator work. Bing, bing, bing. 30.7 units or centimeters. Now in part C, this is where we get into trouble. You know, if I want to find side B, which I should be able to do because I got the opposite angle, but I don't have an angle side pair anywhere else. I don't have, you know, angle C, so I don't have the angle side pair here. I don't have angle A, no angle side pair there, and I don't have enough information to find one of those angles. Like in B, I didn't have angle L, but I was able to find angle L just using some of the angles of a triangle, but I can't do it. So no angle side pair. We're stuck. Sad face. Until today. And that's when we'll use the cosine law. As you probably remember, hopefully from grade 11, that we'll use the cosine law for that. So let's get into that straight off. The expectations for today are to solve problems involving non-right triangles, again, including real-life applications using the cosine law. And this is the last sort of lesson. This is the last sort of stuff we'll do. And it's review. So it's no problem. Now, It says in questions for like this one from the 3-minute review, we don't have an angle side pair, so we don't use the sine law. Instead, we use the cosine law. And there's a bunch of versions of it, just like in the sine law. There was a big long thing that we only used a couple of pieces, but depending on what we want to find, we use one of these formulas. Now, notice it looks pretty bad, confusing, but it's not really. The first part looks like Pythagorean theorem, right? Where if this is the side I want to find, side A, it starts like Pythagorean theorem. And notice that it starts and ends with the same letter. So if it's A I want to find, angle A is the one that I have. Now I do have to remember the rest, but that shouldn't be so bad. Now where this comes from, I did the development of the sine law yesterday. I'm not going to do the development of the cosine law. Probably in grade 11 you had a spreadsheet exercise or maybe geometry sketchpad, but you know, it's review for us. We're just going to pound through some examples and start thinking about the test. Now, there'll be some times where we're not given an angle side pair and we want to find an angle. I think that's what our next, if we don't have an angle side pair, need to find an angle, that is, we'll have all three sides, we use a rearranged version of the cosine law. And so here, if we want to find an angle, and we're given all these sides, all the sides are known, A, B, and C will all be known, then I want to find this. Well, I need to rearrange this so this is my formula. The left side of my formula needs to be cos of A. So what I'm going to do is put that on that side and put that on this side. Just subtract A squared from both sides and add 2BC to both sides. Subtract A squared, right? Change the side, change the sign, some people say. Subtract from both sides. And now notice I still want to get that alone, so I need to get rid of this. How do I get rid of that? I divide it on both sides. Divide by 2BC. Divide by 2BC. On this side, that chunk will cancel out. And then I think that just about does it, doesn't it? B squared minus C squared, or B squared plus C squared minus A squared all over 2BC. And that's the formula. Notice that it's still cosine law, kind of looks like Pythagorean theorem, starts and ends with the same letter. Cos A that we want to find, it's A squared that we have to subtract. That's an important thing. That's the one that's subtracted. And the rest is just a pattern, BC, BC. Okay. Maybe the toughest part, not even remembering this, is putting it into a calculator, as we'll see. But there's the cosine law for angles, and it says other forms are similar, but we'll practice writing down cosine laws in this first example. Example 1, for the given triangle, write the cosine law that would be used to solve for side W and another. So this is two questions. So side W, it's going to start W squared because it's the cosine law. Looks like Pythagorean theorem when we start. And then the pattern I just need to remember. Ends with the same angle we started with. So if we wanted to find the W using the cosine law, all of these things would be known. And then we just pound this into a calculator. Now for angle X, starts like this. And the one that's subtracted is the X, right? So here I'd have W squared plus Y squared minus X squared, because it starts and ends with the same value. That's supposed to be a Y. And then I got to remember the rest of the pattern. And there's the cosine law for that. So let's put this into use here. In this one, find angle C. So in angle C, I've got, notice, no angle side pair, so I know I can't use the sine law. No angle side pair. I'm going to use the cosine law. For angle C, it's this one. Well, if it's C that I want to find, the other two are the first ones, positive, and I'm subtracting the one that I want to find. And again, I am okay if you start with, this is your first step, and you start with the substituted version. A is 8 squared plus 7 squared minus the side that, not 7 squared, B is 6. right? Subtract the side that I wanted to find. Right? C is 7 over 2 times 8 times 6. Now the toughest thing here, I think, is putting this into your calculator. And you can put it into your calculator in one step, at least to get to the decimal version, but there's implied brackets here. So I would actually put that into my calculator in one step. Bracket 8 squared plus 6 squared minus 7 squared, bracket divided by bracket 2 times 8 times 6. And then you get an answer. That's a decimal, right? And that's about 0.53125. Actually, I think that's exact. And then I do the inverse cos of both sides. That's a bracket. That's supposed to be a bracket there. And that is 58 degrees. So, well, okay, that sounds fine and dandy. That's 58 degrees, and it's a acute angle, so it checks out. If I think of what I talked about yesterday, the ambiguous case, that was using the sine law. Does that come into play using the cosine law? And it does not. We don't have to worry about it, because if I think of the cast rule, where is the cosine positive? Well, it's positive in the first quadrant. That's the 58 degrees that we found, but it's also not positive again until the fourth quadrant, right? Where this is 58 degrees. It's hard to fit in, what's that, a 302 degree angle in a triangle. It's impossible, right? So when we're using the cosine law, we don't worry about ambiguous case. So no ambig case for cosine law. For cos law. That's only sine law, and it's only when we're finding angles. All right, so side C, notice no angle side pair here, so we know we're using the sine law, and I want to find side C. So starts like Pythagorean theorem, and the adjust, end with the same letter you started with, and I'm just going to pound this in now. A is 7, B is 5. The angle is 40 degrees. And then that can go into your calculator in one step. And I just pound it right in. That's about 20.38. Notice that's c squared. So to finish this off, we've got to take the square root of that, which is about 4.5 centimeters, pounding that into a calculator. And notice that makes sense. We've got a 40 degree angle, which is a pretty small angle, across from a pretty small side. That makes sense. Last question of the whole unit. A problem, a word problem. Ferd takes a shot from the left face-off circle. This is a hockey question, I guess. The near post is 38 feet away. The far post is 41.5 feet away. And the net is 6 feet wide. Within what angle must Ferd shoot to get the shot on net? So I guess here's Ferd. Draw this diagram. There's a net over here somewhere. Left face-off circle, so he's to the left of the net, and this is hockey nets. And like a hockey net here. So it says this is 6 feet wide. The near post is 38 feet away. The far post is 41.5 feet away. And we want to find within what angle must he shoot. Call that theta. I guess we could have called it F for Ferd. But this is the three sides. We don't have an angle side pair. We have to use the cosine law. And off we go. And I'm just going to substitute into it. Notice the one that I need to subtract is the one that's opposite the angle that I that I need to find. So 38 squared plus 41.5 squared, subtract 6 squared. That's the important one. That's across from the angle theta. That's the one that's subtracted. And again, Be careful when you put this into your calculator. Use brackets, implied brackets. Bracket 38 squared plus 41.5 squared, subtract 6 squared, bracket divided by, division bar, bracket 2 times 38 times 41.5. And then what do we get? That is should get about 0.9925, about. Inverse cos of that, not worried about the ambiguous case because it's cosine law, we don't worry about that. About 7 degrees. That makes sense. Skinny little angle it looks like. Bird must shoot within 7 degrees. Notice there's a goalie in there too, so it's pretty difficult thing to do is to score from the face-off circle. That's it. Tomorrow review, test the next day.